So thank you everyone for attending today. And Leigh, you can unmute your microphone if you did and begin your presentation.
Thank you so much, Robin. And thank you everybody who persisted with us despite the reschedule from last week. I had jury duty of all things, couldn't predict that coming. And so I really appreciate everyone's willingness to shift by a week. So today I'm going to be talking about forest pests from the carbon sequestration perspective, which is a pretty big departure from what a lot of folks normally associate my body of work with, which is firewood and forest pests. But actually, I'm really pleased to say that I do more than just firewood. And so this is a really interesting multidisciplinary and multi-partnership project that I worked on from start to finish almost over the course of the last 5 years. My biggest partner in this work has always been Brendan Curian. He used to be an employee of the Nature Conservancy's Adirondack chapter in the state of New York. Then he moved to Cornell University for his graduate degree, and now he actually works for the New York Department of Environmental Quality, I believe, but it's possible that it's a different New York State agency and I'm getting that wrong. Sorry, Brendan, in advance. And I'm going to be showing about the first half of this presentation is Brendan's slides that he and I prepared from prior presentations on this topic. So I just want to go right up front and say thank you, Brendan, for making not only an amazing project over the course of the last few years, but also making sure that we always have really great slides. So we're going to talk about forest pests that damage, stunt and kill trees. And we're going to go from the Western United States, where we have things like the shot-hole borers, represented by the picture you're seeing on the sort of center of the screen, as well to the Eastern United States, which I'm representing graphically here with Asian longhorn beetle damage from the original Worcester, Massachusetts infestation core. So let's get on it. Also, if I stumble over some of the early slides, let's just say that it's hard when you're giving somebody else's slides occasionally. So the end result, so we're going to go from start to finish quickly. The end result is this paper, which is in Frontiers in Forest Health journal, and I highly recommend everybody at least read the actual, Frontiers in Forest and Global Change. At least read the actual abstract, if not look at some of the figures and so forth when you're done with the course of this presentation, because it's a great paper and we had a lot of really great partners that helped us write it. The Nature Conservancy also put out some really nice press materials for the layperson, like this image that's on the bottom right showing our press releases from the actual nature.org page. So there's lots of different resources you can dig into. I'm going to try to keep my presentation on the shorter end, the less descriptive end, because that'll allow you to ask questions, which I find to be a lot more productive than me just talking at an empty screen of webinar participants. So first of all, one of the funny things that we get right off the bat is, wait a minute, what the heck are we talking about? And Brendan made this great slide that reminds us all that trees take carbon dioxide and water, they put it into a little engine, which uses light and chlorophyll to create essentially biomass, which you could think of as wood and leaves. But most importantly, the formation of glucose traps all those carbon atoms into complex carbohydrates that themselves build wood and bark and leaves. That is the core of carbon sequestration by forests right there. So this is the process that I'm going to be talking about, pulling things out of the atmosphere and turning it into glucose and building a forest. Sorry, it doesn't. Oh, you know what? Brendan has some animations I forgot about. Sorry. Okay. So many things can disturb this process and make it not as efficient. And many of those things are natural and some of them are not. Some of them are both natural and at higher than ordinary incidence because of human influences or climate change. So you could have landslides qualify as a disturbance that could potentially impact carbon sequestration, forest fires, wind events, so blow down, tornado, etc. Extremely high ungulate density is a particularly interesting sort of anthropomorphic element that comes into play across the United States, depending on where you are specifically. And then, of course, invasive plants that can deeply affect the ecology of the forest, shown here with kudzu. So all of these disturbances can impact forest dynamics in a way that impacts forest carbon sequestration. I will also do my best to keep an eye on the chat. So if somebody has a question that they think they want to like have me focus on a slide, please just jump in on chat and I'll keep an eye on it. So the other disturbance, and the one that we're going to focus on today, is forest pests, which is the only one that wasn't on that prior slide. So in Sandy Leopold's paper in 2013, we all sort of can see that the forest pest per county numbers can be very high. And they are particularly challenging in the Great Lakes and New England Mid-Atlantic region, which is a historical byproduct largely of the way that global trade has worked for the last 150 years. But it's increasing on the West Coast. And in order to get a grip on how all of this is impacting carbon sequestration, we had to look at all of these counties. When I said that the Western states has an increasing amount of forest pest damage, this graphic that's a little bit more recent, you can see that it's highly localized. So areas in the Great Basin that simply do not have a tremendous amount of trees, or the desert Southwest that have very limited trees, do not obviously have a lot of damaged tree areas. But then we have a lot of high altitude forests and medium altitude forests that have tremendous damage that are in both native and non-native pests. So to bring together to answer the question that we wanted to answer, which is, has all of this recent insect and disease disturbance actually reduced the capacity of US forests to sequester carbon on the whole? And if so, by how much? We convened a multidisciplinary group of people shown here in order to really get at the core of the question. So we needed both data oriented folks that could do the types of analyses of huge data sets from the US Forest Service, as well as conceptual folks that were able to do the synthesis necessary for the final findings and discussion, conclusions, et cetera. So it was a really interesting, like I said, multidisciplinary, multi-entity effort. And as I said, the data set that we used was absolutely massive. It was the National Forest Inventory, which is maintained by the US Forest Service. And there's a couple of things that are worth mentioning on this. The level of data collection in the National Forest Inventory is tremendously detailed. But of course, every single data set has both strengths and limitations. And there's the strengths of the carbon measurement and the growth measurement and the landscape coverage of the National Forest Inventory data. It was incredibly important to getting this work done, but the limitations, such as the fact that the type of insect or disease that was causing the disturbance was not directly recorded, as well as the fact that the US Forest Service does not work in Canada because it's the US Forest Service. So we were unable to use this data in a way that we could also analyze Canada simultaneously, you know, so pluses and minuses. But the moral of the story and what I want you to take from this is that there is such a wealth of information on insect and disease disturbance in these plots. But that doesn't mean that every single piece of information that we ever could have wanted was present in the data. Now, what we were really looking for is the carbon sequestration capacity, which is how much carbon is accumulated in live trees in forests. And so you have to start with a live tree or a forest and get an initial measurement. And then you have to measure it again because it's a rate. And this is going to come into play intensely. So a snapshot of all of the carbon on the landscape doesn't tell you the rate of sequestration, of course, because you need a starting point and a stopping point. And so we had to use a time period in order to assess the rate of change. And the remeasurement period, which is a time period that we used, was 2001 to 2019 to ensure that we had a starting point and a stopping point. One issue that we ran into that I'll get to is that not every single region of the National Forest database had sufficient remeasurement occurrence in this period. So for instance, if we caught that section in the middle of a remeasurement period, we didn't have both a start and a stop. So we're going to use a lot of like fancy terminology, megagrams of carbon per hectare per year. In the end, the unit here doesn't really matter tremendously because we're just talking about a rate of change. But that's what that elaborate abbreviation stands for. So let's, I'm going to flip through some of these. I like it better like that. There you go. So what did we find at its core? The average annual change in live tree biomass average was that with no disturbance, we were seeing a increase. So the average being sort of the baseline of 1.1 teragrams, or sorry, 1.44, excuse me. But when you get into the disease disturbed areas, that's lower. So you're seeing only 72% of the baseline 100% rate, which is the 1.04. And then when you get into the insect disturbed below that, shown in the red, it's a lot lower. It's about a third the estimated annual change. Now, like I just said, one of the limitations of this data is that we were not able to clearly define which of the diseases were native versus non-native and which of the diseases were, excuse me, insects were native and non-native. However, we'll get to that in a moment. When you look at the map, you can see there's some very suggestive patterns here. For instance, insect areas that have a tremendous impact at the time of the remeasurement interval from emerald ash borer light up in red in these spots. These are insect disturbed plots. And you know that a tremendous amount of that damage must be coming from emerald ash borer. And likewise, the root diseases of the western forests, as well as many of the diseases of the eastern forests, are lighting up in the blue dots on the right. The no remeasurement period is that time-based issue I mentioned. We used estimated sort of global estimates to rough out the data for the no remeasurement period. So basically just using a proxy measurement to make sure that we could extract some information from the interior west states that we did not have a before and after clearly demarcated in the data. So this is a lot of carbon loss. It's disturbing, frankly, to think about this. I do want to put into perspective the fact that native insects and native diseases should be causing natural perturbation and disturbance, sometimes at very large scales across the United States, because that's just basic forest ecology. Insects and diseases cause losses of carbon, but the thing is that they should cause them in a way that eventually has net more or less zero effect over time, because that would imply that in general, our continent is in a state of equilibrium. When you don't see that net more or less zero over time, that suggests that something is being truly lost. So we are not maintaining our carbon sequestration potential as a continent, which is one of many things that we would like to either do or improve upon in order to mitigate some of the very serious carbon issues that we're seeing with climate change. So the total loss is really substantial. To put it into, sorry, I'm on the wrong slide. I'm sorry. So we also have a really conservative total loss estimate. The National Forest Inventory's definition of disturbance does not account for low intensity disturbance. So it only counts as a disturbance that ends up in the database if it's over 25% of trees in about a half hectare, or over 50% of the trees in a given species in that same measurement area. So, you know, that's a pretty high threshold. You can have a lot of disturbances that don't quite make the cut. And so this is a conservative estimate of loss of carbon sequestration potential. And then also we lacked the remeasurement data from the Rocky Mountain states. And we know that there's a lot of insect and disease damage in that area. And we were able, like I said, to kind of rough out the data using global rate, not global United States, not global rates internationally, but using the generalized rate in order to estimate for the losses, we were able to estimate what was happening in the Rocky Mountains. But we also know that the interior West, it has had a tremendous amount of insect and disease damage. And so likely that's a significant underestimate from the actual truth of the matter. What do these numbers really mean? Well, when we look at it, insects and diseases, instead of maintaining roughly an equilibrium, which is hopefully what you would see, are actually reducing sequestration by approximately 9% annually. That's deeply problematic. And if you try to put it into perspectives that you can really understand, it is as if we added the carbon emissions from over 10 million passenger vehicles annually. So as if we were doing that, we're not actually doing that, but that is the scale of the impact of this loss. So when we think about all the actions that we can take, you can see this is a very significant part of the bigger carbon portfolio of mitigation actions that we could take, is taking this 9% and doing our best as invasive species professionals, forest management professionals, and policymakers, and you name it, to drive that 9% as close to 0%, which is what you would hope, no net loss of sequestration potential, as is feasible. So what are these implications? Well, we certainly need to improve the forest pest prevention in international trade policies. I hadn't gotten into this aspect of it because it's kind of the latter half of the conceptual arc of this paper, which is to say what can be done from the invasive insect and disease perspective. And what that comes down to is essentially, well, we could do our best to make sure this problem does not get worse with the addition of new species or new subspecies or new genetic strains or new hybrids of invasive species themselves. And the best way to do that is to strengthen and enforce and inform and improve forest pest prevention policies at the international scope. I see a question in the chat about how much carbon sequestration loss is occurring from forests and wildfires. That's a really great question that would be better addressed by a forest fire research paper. It is substantial, but of course, there's also a lot of natural forest fire that is necessary to maintain healthy ecosystems. So again, it gets to that same conceptual reminder that I mentioned earlier, which is that forest insects and diseases that are native, they belong in North America, and they will cycle up and down or remain at low levels on a landscape, depending on their ecology. They're natural and they're necessary. And in theory, they should not be changing the biggest measurements of carbon sequestration unless they are being perturbed by influences like human landscape change, like climate change, etc. The same exact concept applies to forest fire. Forest fires should not be causing massive losses of carbon when looked at from across the entire continental scope, unless there's something wrong with the system. And that's why we're looking at climate change as a whole, which is if we have these bigger mega fires, there's something wrong with the whole system. So I don't have a number to answer Thomas's question because I'm not a wildfire specialist. However, I will say that the problem has a distinct similarity to the problems that we're seeing with insects and diseases, which is that some fire is necessary and important, excessive fire is problematic. We can also refocus ourselves onto the core of the paper, which is to say, what is the implication of this disturbing finding that 9% of carbon sequestration is being lost due to the influence of invasive insects, diseases, and native insects and diseases? Well, we could mitigate some of those losses through improved, more direct forest management in order to really get at the core of the problem. We could, figure out ways to do better. And sometimes that will mean treatments. Sometimes that will mean prevention. Sometimes that means slow the spread. Sometimes that means improved professional education for the forestry sector in order to improve forest harvest Management, I mean, it's going to really be local solutions for local problems. However, they all need to be addressing the issue of excessive insect and disease-based damage and mortality, because otherwise we're not going to be able to take advantage of the natural forest carbon sequestration that trees provide. And then also, this paper was not designed to be the be all end all. No paper is. And so there's a lot of additional research needed. As I mentioned, the nature of the data that we had did not really allow us to adequately define which parts of this damage was from native and non-native at a granular level. We did try to overlay damage maps at different scales in order to do so. And essentially, long story short, it did not work in a scientifically defensible way. So we have to stick with a broader scale findings. Also, we were unable to use Canada data. That's a problem because Canada contains massive forests that are also under influence of insect and disease. And then also the remeasurement issue for the interior West states. Were we to do this project again in a different time frame, we could incorporate interior West states more intentionally, but we had to, like all scientific papers, at some point you have to make decisions and move forward. So some of the actions that we could take on international scale are outlined here. Historically speaking, there are a lot of plants called plants for planting that come in internationally from international sources that can bear forest insects and diseases, either in the wood, the leaves, the soil, whatever. There are a lot of regulations that now are in place to protect North American forests from the plants from planting pathway. So for instance, it is absolutely no longer legal to do some of the more egregious bringing in of, for instance, like a bald and burlapped tree sapling from overseas. That is not a thing you can do. However, there are some things that you can do that perhaps are still ill-advised. And so supporting the current regulations and the full compliance activities to make sure they are adhered to is incredibly important. But then also there are some lingering risky pathways and groups that remain. For instance, there's some new regulations that could be put in place in theory on the higher risk genre of trees, woody plants, et cetera, that have a lot of congeners, so very closely related trees in North America. It is possible that a regulation on that could reduce the risks to North American trees. And then also different types of nursery stock have different types of risk associated with them. So for instance, a plant in soil presents an issue of potentially bringing in soil-based pests, whereas a plant that's bare root does not, or at least has much lower risk, right? And so making sure that the remaining allowable nursery and plants for planting stock that come in are in the very lowest types of risk groupings is another step that we could take. So these are areas where we could reduce the chance that new pests get added to the North American forests and accelerate these carbon sequestration losses over time, because right now we have a situation that's challenging with only the pests we have. It could get much more challenging if you add more. Likewise, another major way that pests could enter the United States and Canada and Mexico that is regulated but stands to have improvements placed on those regulations is solid wood packaging, represented here by this pile of pallets. Now, solid wood packaging is not just pallets. It also includes a number of other materials such as crates, those giant spool things that you see cable on, as well as this sort of blocking material that's named dunnage. All that material is supposed to be treated with an approved treatment, which is typically speaking a heat treatment in a kiln at set temperature and time before it moves internationally. So it should all be rendered pretty much biologically inert. But regrettably, in a global economy, there is fraud. Sometimes there is unintentional non-compliance. So basically they didn't heat it hot enough and didn't realize it. And then there's also just bad actors that might bring in untreated materials and try to come in under the wire and resist being detected for that illegal behavior. All of those things add up to a system that is good but certainly has many points of potential improvement. Now, the solid wood packaging material pathway is particularly important because some of the biggest, worst forest, not physically biggest, but biggest impact, worst forest pests have come in through the solid wood packaging historical pathway, largely prior to the implementation of this international agreement that I just mentioned, the treaty that serves to hold up what's called ISPM 15, which is the treatment requirement. So a lot of the pests that we talk about, from emerald ash borer to Asian longhorn beetle, as well as many others, likely came from solid wood packaging prior to the implementation of ISPM 15. But those timelines are not perfect. It is not completely understood because you cannot turn back time and see which bug crawls out exactly where, whether or not all of those infestations came from before the treaty was put in place and implemented by all the partner countries. And in fact, we know that some of these materials are still getting in with live insects in them at a rate that, no matter how fractional to total trade, is still high enough when we talk about billions of pieces of solid wood packaging to be deeply worrisome. And so folks like myself and my many colleagues and partners that work on the issue of forest pests and international trade, we need to look at continuous improvement of the regulations on both plants for planting and solid wood packaging, and all other trade that can serve as a pathway for forest pests. Because if we're going to get a grip on these losses of carbon sequestration as a continent and to try to mitigate this problem, adding more pests from more parts of the globe is not going to help. It's only going to make this far more difficult. So like I just said, prevention from overseas is really important, and it's a lot more efficient than early detection at the ports. So it is a preferable option in terms of whether or not you can prevent something from ever entering versus capture it at the edge of its invasive species curve. But certainly catching something at the edge of the invasive species curve, so being adequate early detection network across the nation, will enable an effective response if a new pest does enter North America, because once it gets to large amounts before you find it, it's extremely difficult to have an effective response. Furthermore, once things are detected, you have to respond rapidly, because otherwise, no matter how early it was, it may not be early enough once you have boots on the ground or capture the science that you need in order to minimize impacts or enable an eradication program or an adequate and effective management program to keep the damage deeply limited. But when all else begins to fade and you've reached a point in the invasion curve, which is an interesting intersection of ecology, biology, finances, political will, you name it, you have to get to the point where you say, how do we have a long-term active management program that makes a difference? How do we, for instance, potentially enable host resistance if that is the stage at which we're looking at? And for some forest pests and pathogens, I mean, this is Emerald Ash Borer University. We're going to talk about Emerald Ash Borer on this slide. We've reached the point now where it is important for us to consider not only, for instance, not allowing more Emerald Ash Borer to come in from solid wood packaging sources. We put in place a rule to prevent that, hopefully, but also to enable the ash trees that are currently either imperiled directly by emerald ash borer or currently indirectly imperiled, such as Oregon ash found on the western coast, to have resistance, because we can no longer use these first couple steps on a pest like emerald ash borer. We can no longer really use early detection and rapid response effectively at the continental scale. We might be able to prevent additional introductions. For instance, none of us really want an additional introduction of emerald ash borer to like the port of SeaTac, Seattle, Tacoma. That would be bad, but nonetheless, the biggest threat is now coming from inside the United States and Canada. And the graphic on the right is just a really neat visual representation that I appreciate from Jennifer Koch at the U.S. Forest Service, who's working on a breeding program for resistant ash. And what it represents is that when you do find potentially, 1 in 1,000 or 1 in 10,000 resistant ash trees through observing them in the ecosystem as not having the depth of damage as some of the other ash trees that are being affected by emerald ash borer, you can place laboratory reared eggs on those ash tree clones in a controlled environment using basically like cotton tape. And then some of those ash tree clones that are actually capable of functional self-defense will, on the right, you see the wood actually kind of encloses and there's chemicals that can actually kill the larvae within the clone. And then on the left-hand side, the larvae of a less resistant clone is still alive and wiggly and well in the natural color. So host tree resistance is feasible, and it's going on the geological timescale to be part of the carbon sequestration answer. Because if we want to put ash trees of all of their natural genetic variation and ecological niche back into the landscape of the emerald ash borer affected parts of North America, we're going to have to support that carbon sequestration with resistant fraxinus, resistant ash trees on the landscape. So when we go all the way from start to finish of my, reminding everybody that what we're really talking about is pulling carbon out of the air and making a tree. You cannot make a tree that reaches maturity if it is an ash tree in emerald ash borer territory, unless you go all the way to this part of the continuum here, which is to breed resistant trees. Now, this is only one of many examples. Different forest pests require different actions, different management, and not all can be bred in order to achieve resistance. This is unique. Well, it's not unique. It is one possibility of many that appears to be feasible. So it's a tricky place to end up at the end. I see something in the Q&A. I'm just going to keep it. I will address Thomas Valley's question in a minute, because that's kind of a end of Q&A question. Okay. So yes, as I just mentioned, at the conceptual end of this continuum is the breeding of pest-resistant trees. It is also a place that is not ideal to reach. It would be far better, for instance, if we had never had emerald ash borer at all. And we know that, but it's worth repeating because we don't know what's coming next. And if in 20 years we look back and we say, wow, we really should have more carefully closed the plants for planting pathway risks, or we should have really enforced our solid wood packaging regulations so much more tightly, because can you imagine if we hadn't had Pest X that we've now been watching, functionally eliminate all red oak, some nightmare scenario like that, there was a recent paper talking about pests of oak that's really thought-provoking. Hindsight is 20/20. You don't want to get to the point where you have to breed resistant trees. If you're already there, it's worth doing, but you don't want to get there. So I successfully kept myself to a short enough presentation to allow for a really robust conversation, which I'm very excited about. If anybody has more direct questions or comments that they'd like to reach me personally at, that is my email right there. It's lgreenwood@tnc.org. I highly recommend, though, that if you want to talk about data, if you want to geek out about how NFI plots are done, that sort of thing, please reach out to Brendan. He was the data guru, and this was his graduate thesis. He knows all the smaller details, as well as, of course, all of our partners that I can click back to on the other slide for reference. So that wraps up my direct presentation. I'm going to click back actually to those folks because I want to make sure they get the recognition they deserve. It was a really multidisciplinary writing group. I'm sorry to have to flick through all of these. I don't know an easier way to do it. We're almost there. There we go. Okay. All right. Robin, do you want to MC from here a little bit?
I can do that. Yes. Okay. So you've got Thomas's question, right? How
Yes.
is the state able to earn carbon sequestration credits for projects affecting only a portion of the state forest if the entire state forest is losing sequestration capacity due to disease and insects? This is this cherry picking?
Yeah, this is, I mean, you're getting to the real heart of the problem with carbon credits and accounting systems. I can't answer your question directly because accounting systems and carbon credits are so tremendously complex. And you are absolutely right that sometimes, in some cases, these projects do amount to a form of cherry picking. However, many of these projects are legitimate. And I am not a forest carbon accounting professional, so I cannot tell you with your particular question whether, you know, how that works. I'm just going to be frank. But what I do know is that it's going to take a lot of constructive criticism to make sure that as we incentivize carbon sequestration and carbon protection projects, we're not falling into that pitfall that you're alluding to as a community of forest health professionals of accounting for things that actually are not net benefit. So it's a really interesting and thought-provoking issue that I am not prepared to, you know, really answer. However, I agree it's troublesome and we need to really address it head on. We can't just pretend that it's going to work.
Okay. If we're looking, if you have other questions, we'll keep this open for a couple more minutes. You're getting a thank you. It says thank you for presenting this so clearly.
Yeah,
that's always a good one. Jordan Stransky says, are there many native pests that pass the 30% damage threshold?
That's a great question. Yes, absolutely. I would have to dig deep into it, but things like mountain pine beetle, western pine beetle, Douglas fir tussock moth, southern pine beetle. So you've got, I live in Montana, so I'm good at calling out pine beetles, but there are many forest pests that have cyclical bases where they have sort of catastrophic, even native pests can have catastrophic ups and downs, and they cross that 25% threshold or the 50% within a given species threshold. So yes, absolutely. And we see that with diseases too. I actually don't really know my disease world as well as I do my insect world, but I do know that the excellent Forest Service partners that we worked with, Grant Domke and Brian Walters, can, you know, really answer those questions if you'd like to dig into them. And I highly recommend you reach out directly to them for clarifications on which specific pests and pathogens we see in the native realm that can cause this level of damage. And there's nothing necessarily wrong with the damage they cause or the disturbances they cause if they're, you know, at large landscape scale equilibriums. That's just how forests work, right? It's part of our natural successional models across all of North America. It's the problem is when it becomes perturbed to the point of excessive damage, which is typically because of human action, intervention, or damage itself. Okay, we got a question by Jeff Garnis. Are there any, well, first of all, thank you for the mention, great talk. Are there any patterns and damage rates that you could see with respect to latitude or temperature? We did not look at that. It's a really good question. I can tell you right now that there are some native forest pests that are moving north and acting, to oversimplify, a bit more erratically because they're entering territory they'd never lived in before as part of their native range. So the poster child for that phenomena is southern pine beetle, but there are other examples. So while we did not notice or call out any damage rates with respect to latitude or temperature, which would also apply to altitude within trees, across mountaintops, especially in the Western United States, we didn't see that, but our data probably didn't have the sufficient granularity to see it. So I don't think that doesn't mean it wasn't there. But we do know that the impact of increased forest temperature and more unpredictable rainfall and features like that are happening now in the modern climate change universe are impacting the ranges of native insects, which is effectively like it's changing the latitude, and definitely it's changing the temperature.
Okay. More questions, folks? I will leave it open a couple more minutes again and see if we have any more questions.
Oh, we got a shameless plug in the chat. So everybody read that, please. Okay, so we have a question in the Q&A, which is, will climate change impact forest pests? That is absolutely a yes. However, the direction of impact is not always clearly positive, negative, neutral. So in some cases, forest pests are able to hone in on previously healthy trees that are rendered more stressed because of the impact of climate change. But in other cases, forest pests may reach a point where they cannot reproduce because of some change in the environment. Perhaps it's too hot for their eggs to be viable in the environment where they would typically require a cooler incubation period for their eggs. There's all sorts of ecological intersections in terms of what are the limiting factors on forest pests that come into play with climate change. I would say that because so many forest pests do take advantage of stressed systems, that is kind of their natural ecology in many, many cases, generally speaking, climate change will increase the impact, damage, and fatality rates of trees from forest pests, but it's not a universal, and it certainly won't be evenly allocated across the landscape. So it's a really good kind of theoretical question of like, well, will all the damage be the same, but just farther north? And the answer to that is pretty clearly no, it's not going to be as simple as that. Okay. I'm going to go to Elizabeth Barnes' question. How do you think this research will change the conversation around invasive species or conversation around climate change? Also great talk. Thank you, Elizabeth. We did this research in order to sort of raise our hand in the conversation of invasive species and climate change. The actual impetus for this paper, and I'm entertained that I didn't tell Elizabeth to ask this question because it's so perfect. The actual impetus for this paper initially was the Nature Conservancy has an internal invasive species professional development group. Basically, it's colleagues who talk to one another to make sure that we're all exchanging information and following best practices. It's a great group of people. And in approximately 2018, if my memory serves, we had an in-person meeting. I know, gasp, crazy. And we said, what invasive species scenario is going to have the largest climate change impact and vice versa? What are we most worried about? What are we as a professional community of invasive species relevant folks within the Nature Conservancy going to see on the horizon from climate change? And we had a really robust discussion for a couple of days, honestly. And the thing that came out was that we were deeply worried about forest carbon and the impacts of forest pests. And this was a conversation that ranged from terrestrial weeds to aquatic, like zebra mussel kind of stuff. It was a global situation analysis. And this came out. And that's when Brendan and I were charged with coming up with a way to assess the level of this issue. Now, I'm going to show you, well, you guys can see very clearly the Purdue University partner, Songlin Fei, who was an outstanding aide in the writing of this paper. During the course of this conversation that I'm alluding to in 2018, he and his team were actually writing a paper that had some distinct similarities about loss of biomass from forest insects and diseases. And so I highly recommend you look at Songlin Fei's paper as well. Because when it came out, at first we were like, gasp, Songlin Fei already did what we were trying to do, but then we dug into it and he didn't quite. And so instead of trying to push away from Songlin, we invited him and said, hey, why don't you actually work on our paper with us so that we can clearly show totally different conclusions in the same thematic group than your initial paper. So the two papers together, the biomass paper that Songlin Fei's team wrote and the Curian paper that I just outlined, together we really tried to show what's happening with carbon sequestration across the United States and forest pests, and how do we need to frame that into the climate change perspective for policymakers, for decision making, for showing the real importance of framing climate change into the forest pest conversation. So there's that. All right. I'm just going to stick with Elizabeth's, and then I'll go back to, I don't know how to say this name, Jabez, maybe, question in just a moment. So Elizabeth says, to follow up, do you think it's important that we increase how much we talk about climate change when we're talking about invasive insects? Personally, I think the relevance is really high. And when it's highly relevant, I think it's important. But there's going to be situations in which case the relevance isn't high. And in that case, I would not create tenuous connections that are not deserved. So let's take an easy example. Perhaps you work with spotted lanternfly. I'm not sure that's going to have a tremendous climate change impact. However, it does have a really big agricultural, human cultural, and interstate trade impact. It may also end up having other impacts that I don't understand yet because I'm not a spotted lanternfly professional. But perhaps climate change is actually really, really low on that list, in which case, no, I would not say we should increase how much we talk about it, because the ecology and the social systems around that insect may not demand it. But if we are looking at an insect that does have an ecology and a social system that has a lot of climate change perspectives and importance to it, it's going to have a lot of impact, then I think, yes, we should talk about it because it's relevant and people don't always understand the direct connection. The first presentation that Brendan and I gave about this research did not have a slide that reminded folks how exactly trees sequester carbon, because of course, Brendan and I were a little too deep in the weeds to remember that people are not always familiar with that. And it was one of the first questions we got, you know, how on earth is this relevant? Well, let's review. So making sure you make these connections really explicit of how forests sequester carbon and how damaging a tree decreases that, I think is really important when it applies clearly. Okay, so the question in Q&A above that is, do you see any insects extending their host range to, okay, so geographically, yes, absolutely. But I believe your question is actually to other types of host trees. So like perhaps different genres or just different species within the same genre, that kind of thing. Oh, sorry, genera. I'm saying the wrong pronunciation. I haven't seen that, but that definitely does not mean it does not happen. One of the things about invasive species is that they often perform really differently in the invaded range than they do in their native range. So, you know, for instance, the issue of emerald ash borer belatedly being found to infest white fringed tree, it doesn't mean that it wouldn't have infested white fringed tree elsewhere. It just means that we didn't recognize it at first because it was an invader here, as opposed to in its native range. So I think one of the tricks with insects and diseases expanding their hosts is that they are simply able to reach more hosts in an invaded range than they were in their native range because they already would have maxed out their ecological niche over geological time. Which is to say that insects perform weird and diseases when they are introduced to new areas because there's all these new opportunities for them from an ecological perspective.
Okay, let's see. Have you got them all now?
I mean, I don't see any other, I don't see any other questions, but I'm thrilled that we still have 10 minutes in case somebody has had a moment of clarity and has any questions.
Okay. And again, too, also, folks, if you decide after we get off the webinar and you think, oh, I should have asked this, you will be getting, if you didn't write down Leigh's contact info, we will be sending you an email tomorrow with all that information on it as well. So never fear, you will have some way to contact her if you do have questions later on. So let's see, we got in the chat. Thank you very much. That was from Jabez. So
great. Yeah. And, you know, it's really interesting to hear the different types of questions we get from different types of presentations. Brendan and I have given a number of presentations to different audiences. So for instance, we gave a presentation for National Invasive Species Awareness Week, which was back in February. This is actually derived largely from that presentation. And, you know, people were really hyper-focused on the invasive species aspect of it, as they should be. You know, this group, I've just received several questions on the climate change aspect, which is really fascinating. You know, future directions for this research from the Nature Conservancy are not really currently clear. We don't have an intent to redo the study to, you know, for instance, a lot of folks have said, are you going to redo it to include the interior West? No, we're not right now. That's not our intent. I mean, in theory, we might, but we don't have any plans to. But I do highly recommend that folks that are in a position to look at questions like this with regards to not only biodiversity losses from invasive species, but also climate change relevant losses from invasive species. Just really explore that dimension. If it applies to your work, it's important. And that's really what we were trying, the whole point of this paper was exactly that. This applies to all of our work, and therefore it is really, really critical for us to look at carbon sequestration in this lens when we do our invasive species management work.
Okay. And with that, I think I am going to close the webinar now and thank our presenter, Leigh Greenwood. You did a great job. Everyone seems to be getting a lot out of your talks. Yeah, you gave one just not too long ago as well. So thanks for all your participation and all the good information you've shared with us here on Emerald Ash Borer University. And folks, thank you so much for participating in today's webinar. And with that, I'm going to close the webinar, and everyone, please have a good day.